Okay, so we're trying to find the point on this line that is equidistant from B and from A, which means there's some point on this line where if we were sitting at that point, we would be the same distance from A as we were from B. So we look down here, for example, to 9, 0, it looks like we're closer to B than we are to A. And over here at 0, 3, it looks like we're closer to A than we are to B, so it's somewhere in the middle. Remember, the set of all points that are equidistant from two endpoints is called the perpendicular bisector. It's a line that runs right through the midpoint of the 2 points and is perpendicular to the segment that connects them. And all of those points, any place on that line, will be equidistant from A and B. And you can see here where the perpendicular bisector, I can imagine it going through here, is going to cut through this line down here, and the place where it intersects is going to be the point on this line that's also on the perpendicular bisector, also equidistant from A and B. So to find that perpendicular bisector, we're going to have to find the midpoint, which I've already done. Okay, it's 6, 9, plotted right there. Next, you have to find the slope of AB. We go here. We started doing that. We got interrupted earlier. Let's see. 10 minus 8 is 2, and 2 minus 10 is negative 8, which reduces to negative 1/4, which means that the slope of the perpendicular bisector will be the negative reciprocal of that slope. So we take negative 1/4, flip it upside down, it becomes 4, and then make it positive. So our equation is going to be y equals mx minus h plus k, where m is the slope and h and k is a point that the line goes through. It could be 6, 9 in this case. So y equals 4 x minus 6 plus 9, and we'll kind of simplify a little bit here. Y equals 4x minus 24 plus 9. 24 minus 9 is 15, so minus 15. So there's our equation of the perpendicular bisector. And we could kind of sketch that in. It's going to go down through here. And let me get a ruler so I can kind of connect that real nice. Second here. It wasn't the ruler I expected to find. It's a better ruler. Okay, so let's connect our dots here. And there is the perpendicular bisector, and right there is the point of intersection. But it's on grid lines, it's not a lattice point, so we'll have to figure out where it is. To figure that out, to find the intersection of the two lines, we'll take the equations of these two lines, set them equal to each other, in a sense, and then find out where they intersect. Now to do that, it would be convenient if I had this in a y equals mx plus b form. So I'm going to do that, subtract x from both sides. 3y equals negative x plus 9. Y equals, negative 1/3 x plus 3, which, by the way, is how I went ahead and graphed this line in the first place. So find this y-intercept with the slope. Now I can say that this expression equals this expression, so let's go through that. So at some point, 4x minus 15 should be equal to negative 1/3 x plus 3. So we're finding the x coordinate right now. Let's see, I will add 1/3 x to each side. 4 is 12/3, so it'll be 13/3 x, and then we'll add 15 to each side, giving us 12. And then we will divide by 13/3, which, let's just make this easy. Use the calculator. So 12 divided by 13/3, clear. 12 divided by 13/3 is 2 10/3, which if you take a look here. Ooh, wait a minute, something's wrong. 1, 2, 3. Hold up, something's wrong. Pause. Oop, there. See, I got an x value that was a little over 2, and I noticed that that could not be the x value here. And something's wrong, and look, 3 plus 15 is 12, it's 18. So there's our problem. So 18 divided by 13/3 is 4 2/3. 1, 2, 3, 4, and a little bit more. 2/13. Yep, that makes sense. So let's turn that into an improper 54/13. Okay. Now, find the y coordinate for that by plugging that into one of these equations. Y equals 4 times 54/13 minus 15. So we'll take this number times 4 minus 15 gives us 21/13, which, let's see, is 1 8/13, 1 and less than 2. So it looks like we're on the right track there. So we have 54/13, comma 21/13. Let's see, was there anything else we were supposed to do here? Nope. That's the point. So this point right here is on the line x plus 3y equals 9, and it's equidistant from B and A because it's on the perpendicular bisector of B and A. To do this, we had to find the midpoint, which we could just kind of do by eyeballing it if I did the calculations, because the perpendicular bisector passes through the midpoint. Then we had to find the slope of AB, because the slope of the perpendicular bisector is the negative reciprocal. So we take that original slope, flip it upside down, and change its sign. Once I know the slope of the perpendicular bisector, and I know a point that it passes through, I write its equation in point-slope form, where, so y equals m times x minus h plus k, where m is the slope, and h and k are the coordinates of a point that the line goes through. Notice that's minus h and plus k. And then, to find out where those two lines intersect, we take the two equations in y equals mx plus b form, and we take the x part of the equation and set them equal to each other. Solve the resulting equation for x. That gives us the x coordinate of our point of intersection. And then we plug that x value into one of the equations to get a y value, and that's the y value of our intersection. We could have also plugged in this x value into the other equation to double check. We get the same y value, then it's an extra sign that we've done it correctly. But we're going to skip that step today because, well, you'd be bored watching it.